Welcome to section 6.1. We're going to be talking about the law of sines. And what we can use the law of sines for is to solve for the missing sides and angles in a non-right triangle, whether it is acute or an obtuse triangle. Previously, we were stuck only working with right triangles. Now we can use for other sides of triangles. Now we do have a couple of things we need to take care of. When you have two angles on any side, that would work, whether it's angle side or angle side angle. So whether the side is an included side or a non-included side. Now we also have the ambiguous case, and that's when we have two sides in a non-included angle. When we have three sides, we can use this, and when we have two sides in the included angle. So if you remember back from when we would when we prove congruence in triangles in geometry. Now, the law of sines. A, that's the side length, over the sine of angle A, equals B over the sine of angle B, equals C over the sine of angle C. What you want to do is you want to pick two of those ratios to make a proportion. So you could either see it with the sides in the numerator and the sine of the angles in the denominator, or in the reciprocal form where the sine of the angle is on top and the side length is on the bottom. Now this law of sines, what it comes from, if you think about drawing the height in this acute angle, if you drop that perpendicular, that's the height, and it creates two right triangles here. So what we could do is the sine of angle A is opposite, which is h, the height, over the hypotenuse B. We could also look at another angle. The sine of angle B is opposite, which is the height, over A. Now we can rewrite these by solving for h, by cross multiplying. So h equals B times the sine of angle A. And on the other side, when we cross multiply, h equals A times the sine of angle B. Now looking at this, they're both equal to h. Since they both equal h, then they equal each other. So B times the sine of angle A equals A times the sine of angle B. And what we could do is we could divide both sides by A. So we get B times the sine of A over A equals the sine of B over, 1 actually. And then what we could do is we could divide both sides by B, and we get the sine of angle A over A equals the sine of angle B over B. And there is the law of sines. Excuse me. That would also work for an obtuse triangle. It's the same exact thing. It looks the same, except the height is outside. And that's just showing you where that law of sines comes from. Let's look at some applications. So for problem number 1, it is an obtuse triangle. Now, we're given that the measure of angle C is 102.3. The measure of angle B is 28.7. So we can find the measure of angle A to be 49 degrees. So there is angle A. And that's 49 degrees because it's a triangle. The sum of the angles is 180. Now, we need to find all three side lengths. I know angle B and I know side B. So if you think about the law of sines, A over the sine of A equals B over the sine of B equals C over the sine of C. So now we have to pick any two of those ratios. Since I have the side B and the angle B, I'm going to use that one for sure. So B over the sine of B equals, and I'm going to find side A. So it's going to be side A over the sine of A. And I'm going to fill in my values. So B, 27.4 over the sine of 28.7 degrees equals A, which we don't know, over the sine of 49. And there we go. There's our proportion. We cross multiply. A times the sine of 28.7 equals 27.4 times the sine of 49. Divide both sides by the sine of 28.7. And A equals. So now, make sure you're in degrees, and when we divide and multiply, we're going to get about 43.06 feet. And now we'll find side C. So once again, B over the sine of B equals, now I'm going to use C over the sine of angle C. 27.4 over the sine of 28.7 equals, now side C we don't know, over the sine of 102.3. So we could cross multiply or just undo your division. Multiply both sides by the sine of 28.7. Oh, excuse me. Let's undo that. Sine of 102.3, excuse me. So C equals the sine of 102.3 times 27.4 divided by the sine of 28.7. So side length C is going to be about 55.75 feet. All right, let's go to problem number 2. So let's draw, we have side A, angle A is 30, angle B is 45. So this is going to be an obtuse triangle. So here we're going to label this as A. This is 30 degrees. B, we'll label this as 45 degrees. And C, 30 plus 45 is 75. So this is 105 degrees. So this is going to be side C, which is opposite that. Side A, which is opposite angle A, is 32 feet. And side B. So we need to find, well, we already found angle C is 105 degrees. So we need to find side C and side B. Now I have both values for A, side A and the sine of A. So A over the sine of A equals, now let's find B first. B over the sine of B. So we have A, side A, which is 32, over the sine of 30 equals side B, we don't know, over the sine of 45. So multiply both sides by the sine of 45. B equals, so it's sine 45 times 32 over the sine of 30, which is about 45.25 feet. And now to find side C. A over the sine of A equals C over the sine of C. So we have 32 over the sine of 30 equals C over the sine of 105. Multiply both sides by the sine of 105 to undo that division. C equals, so you're going to get sine 105 times 32 divided by the sine of 30, which is about 61.82 feet. And then problem number 3. A pole tilts towards the sun at an 8-degree angle from the vertical, and it casts a 22-foot long shadow. So here we have, let's put the sun over here. Now the pole is tilting towards it, so it's a little bit past vertical. So there's the pole. Now the sun is behind it, so the shadow is over here, and the shadow is 22 feet. We can draw a triangle. Now it says the angle of elevation from the tip of the shadow from here to the tip of the pole is 43 degrees. There's our angle of elevation. We need to find out how tall the pole is. We need to find out this value. So we'll call this angle A and side A. Now, there's some other information here. We know if we were to draw a vertical line, that would be a right angle. So we'll call this angle B. Now, angle B is 8 degrees from the vertical towards the sun. So this is 90 and this is 8. So angle B is 98 degrees, which means 43 plus 98. And then we subtract that from 180, we're going to get 39 degrees, and we'll call that angle C. So now we need to find A. This side of 22 feet is C. So we'll use C over the sine of C equals A over the sine of A. There's our law of sines. Now you can use different letters and such. So we're going to have 22 over the sine of 39 equals A over the sine of 43. Multiply both sides by the sine of 43. A equals, so it's 22 times the sine of 43 divided by the sine of 39. You're going to get about 23.84 feet. So the pole is about 23.84 feet tall. So almost 24 feet. If we were estimating, we'd say about 24 feet. All right. In the next lesson, we're going to be talking about the ambiguous case that happens with the law of sines. Thank you.